So we have 5 to 4, but actually, as I've been informed, everybody's here, which is excellent. And we thus can start. So let me introduce our first keynote, Axel Polleres. We are very grateful that he came here to give us a keynote. Axel is a brilliant guy who is on the edge of many things that are number one in the field of semantic web and ontologies. And I will give you the word now. Thanks.
Okay, so
You will switch it.
hello. Hi, welcome everybody. I guess you can hear me. Yeah? So let me switch to the other slide where you don't see a picture of myself but of an airplane. So this airplane has a propeller, and that's actually what I'm going to speak about. I'm going to talk about a project called Propel, which we are currently running in Austria. It's a national project. It's a pre-study on exploring the potential of enterprise linked data. So we, academics and others, talk with industry and ask them what they need and what they expect from us as a community. So I think this is something which is interesting to share with you here because what we learned from this exercise is also some insights of that maybe we actually don't know enough about our community ourselves. So let me talk about the project itself. So a disclaimer first, you had many research talks. This is not a research talk. So this is more or less, and it's also not a scientific project. It's a project where different partners, consulting, like you have IDC here, which is an international consulting firm, and an SME, like the Semantic Web company, who try to sell products in the semantic web realm, and two universities, TU Vienna and WU, funded by this other logo is the Ministry for Innovation and Technology in Austria, should explore a research roadmap, so based on industry needs for semantic web. Okay. So we have started there, basically in Vienna we have these semantic web meetups. I don't know, maybe you have something similar here in Prague, where these companies and SMEs gather, and also non-Austrian, so Cap Center and Cambridge Semantics you will easily recognize are not Austrian, but they have customers in Austria. So there is some take-up already in Austria of linked data technologies, also in enterprise context. But it's still a niche market, and many people don't know. So if you talk to industry people or to IT people in general from companies, they wouldn't know what semantic web is, they wouldn't know what linked data is. They have some idea, but they have maybe a different idea of what we have. Huh? So the goal of this project is to kind of find out what's the market. So to find out what are the requirements and use cases for semantic web in industry, and then eventually also develop a research roadmap. And so the idea was also there to have interviews with people from industry and workshops where we jointly elaborate this. So eventually this should be developed as a model for an enterprise linked data value chain. So something which, for instance, was done in the Lot 2 project, like this data value chain, what actually would be a tool value chain for doing things with linked data. And this is where we started. So this was the expectation. We started like pretty much 1 year ago. So how do we approach this? First of all, of course, we had to understand each other, we had to talk with these consultants people and so on. And then we academics, we go and talk to industry and we want to sell them our stuff. So this is actually the focus of this talk. How do we approach this? Yeah? So what are the lessons learned from this exercise to talk with companies from us academics, and how can we shed some light on us what actually our community itself is? Yeah? So first we better have to understand what we actually can offer as a community, and I think this is interesting to share with us, with you. So what is actually enterprise linked data? What is the semantic web? Any attempts to give a talk with this topic and title have failed, in my opinion, so probably I will as well, but we will have some discussions, I hope. Who we are, so more or less it's a bit of an identity crisis. Yeah? So are we linked data researchers, are we semantic web researchers, or are we just computer scientists? I don't know. I try to just pinpoint of what we did, how we approached it, and what I think we can maybe learn from it. Huh? So this is the journey of this talk. Good. So let's first start with some common misunderstandings. So what's the difference between enterprise linked data and ... The first thing, linked data and the semantic web. So what are the overlaps? So Tim Berners-Lee said once, or is being quoted as having said, linked data is the semantic web done right. The actual semantic web, so the web part of the semantic web, is based on linked data. And linked data is based on semantic web standards. So there's an overlap. There's also some key difference, because often when people talk about semantic web, they see something broader, they see something more theoretical, and they see maybe more than just linked data. Yeah? So they linked data is mainly about links and of carrying on this idea of the web based on links. It doesn't necessarily center around the web as web pages. So when people talked about the semantic web in the beginning, it was a lot about understanding web content and web pages. So this is moved a bit out of focus. It's just using the web concept for linking data. So this link concept. And it's often viewed as being more pragmatic, as more bottom-up than the semantic web. And another quote, which is from a nice former colleague of mine in Derry. We worked together in Ireland, so now he's moved completely to industry, and he said linked data is mainly about publishing structured data in RDF using URIs rather than focusing on the ontological level or an inference. So also true, I don't agree fully, because we try to do some research to do ontological reasoning with linked data as well, but it's hard. So because it's something, linked data as any web data or as any data you find out there, raw data is messy, and you can't just do symbolic, crisp reasoning on top of it, for instance. Good, so you can think of linked data as a more lightweight, somewhat pragmatic bottom-up approach, as opposed to the grand vision of the semantic web. Okay, so then we have linked data versus open data. Often this is named synonymously. You talk about linked open data when you have this cloud in mind. But linked data is not only that. So a lot of linked data or the linked data principles could be used within a company, and that's actually what this project is more focusing about maybe. Openness is a core principle in the design of linked data, and it was the main idea to, so this design issues published by Tim Berners-Lee, where linked data was first mentioned, were about linked open data and were about opening data and publishing data. But linked data as a technology can be used without publishing data. So it can be used for internal and external data integration as a lightweight data integration paradigm. And last but not least, not all open data is linked data. So there's much more open data out there than linked data. For a lot of open data, it doesn't even make sense to make linked data out of it. Because what do you gain by just transforming some tabular data, which you find on some open data portals, into triples? Maybe not much. So, or at least it's a straightforward exercise for you. So you just write something to put around the CSV file, maybe brackets, then it's a turtle file, and then you can process it. You have many blank notes in it, but that's what you could do, yeah? So anyway, so that's the last thing I wanted to say, or for one but last, is linked data versus big data. So that's on the slides, because typically when you mention data in talk to industry nowadays, they say, oh yeah, big data project, I'm interested. Yeah? So that's when you mention you want to do a project about open data, or you want to do a project about linked data, they say, great, we want to do big data. Yeah? So that is also something you have to explain to people when you talk about linked data, because it's not known. so much. So well, linked data as a whole is big, it's dynamic, it's growing. There are some billions of triples in the linked data cloud, just and counting. It is not, it's schemaless in a sense, yeah, so there is no, it's so similar to, similar difference to, which is usually stressed for big data, that it's not mainly data for NoSQL databases and so on. So big data technologies are gaining fashion in our community as well to handle linked data, and it can be used to represent essentially any data. So that was the goal with RDF, that you have a really simple data format which can be used to abstract everything. So then key differences in this linked data cloud, you have data sets which are per se not big data. Yeah? So if you take one of these data sets alone, even DBpedia, the DBpedia dump alone is 5 gigs, that's nothing in terms of big data. Yeah? Linked data is structured and semantically explicit, which is, so we have at least this expectation that we use it along with ontologies, and it's structured, whereas in big data you typically talk about data lakes and you talk about data in different formats, polyglot persistence, and just data from any source. So you want to deal with data from any source. Of course, again, you could map all this data to triples, but maybe that's not the wisest thing to do. Okay, particularly for unstructured and multimedia data. Okay, big data is focused on distributed data infrastructures within organization, and linked data is more, it's also about distributed, but more about decentralized publishing of data. Maybe, so then we could also make a difference between enterprise linked data and linked enterprise data, which basically would just mean we would take an inter-enterprise or an intra-enterprise perspective. Yeah? So more or less, how can companies use linked data within their enterprise to make their data integration more efficient, or how could enterprises use linked data to interoperate with others in a more efficient way? So that would be some things we would need to explain to all these industry partners we talk to in interviews, if we wanted to ask them what they think where linked data or enterprise linked data could be used. One step back, we did not do that. Yeah? Because in principle what we ended up with, we had a questionnaire of 50 questions relating to linked data, and then we realized nobody will understand us. So what we rather did was we had like a very rough structure for interviews with the companies and asked them what are their requirements and use cases, and roughly which technologies they would think would fit those use cases, to find out what we can offer to match these. Good, so taking this business and application-centric view, what we did was we did 23 interviews in total with people from different sectors, from different vertical domains like consulting, engineering, so finance and insurance, healthcare, pharmaceuticals, also from public services, professional, so real estate, and so on. Yeah? So that's more or less the domains we covered, and then we had different roles. We had an HR manager, we had technical people in there, we had people to do risk and compliance, and so on. So you can read it yourself. I don't need to read that to you. But you see, just we had a diverse set of interview partners from industry. Now, okay, so note, that's what I said before. Instead of explaining them what enterprise linked data is, we basically gathered their technology and research expectations from a more general semantic web perspective. So we didn't stop them when they were leaving this crisp definition of enterprise linked data, but it was actually then more about what we can offer from a semantic website. And then we did a workshop where we sit together with the stakeholders, with mainly the more technically savvy or interested people among those who we invited, or those were those who showed up in the end. I think it was also around 20 people, because we also had some additional people invited. And then we came up with these like overall technologies. So what do we have here? We have analytics, computational linguistics and NLP, concept tagging, annotation, data integration, data management, Streaming, dynamic data, important for many nowadays. Extraction, data mining, text mining, logical and formal languages and reasoning, human-computer interaction, knowledge representation. You see already there, I mean, arguably there could be some overlaps here, but it's basically, that was more or less the classification we came up in this workshop. There was then things that have to do about ontology and thesaurus management, data quality and provenance of data, so metadata issues, recommendations, scalability, could also be maybe seen as a part of data management, robustness, maybe not. Searching and browsing, security and privacy, and system engineering. So what do we see here is basically we pretty much ended up in all the topics that are kind of covered under the general hood of semantic web, or that are mentioned in semantic web events and in our research. Huh? So, good, so this is a bit too broad maybe. So maybe to see what we can offer as a start. Okay, let's take the pragmatic view and say semantic web is as the W3C defined it. It's a set of standards. Because the term semantic web was not invented by the research community, it was more invented by the World Wide Web Consortium as this semantic web activity, which is a standardization body. Okay, so we have this layer cakes. I don't want to bore you with that. So what has this evolved to eventually was a set of standards which we've developed over the last 15, 16 years, which serve the purposes of some of these technology areas which we have, which I had presented to you before. So there are standards around linked data, about vocabularies, vocabulary management, ontology languages, inference languages, or rule languages, for instance, and ontology languages, which are formal languages, query languages, and some things which are subsumed under the term vertical applications, which include, for instance, also healthcare, standards for semantic web, or best practices for standards in semantic web in life sciences and healthcare. So, good, so if we put together these standards, this is also like now a set of acronyms. I tried to put together all the standards which have a W3C recommendation tag, so you see it's quite a lot. More or less spread out across these topics, query languages, then some newer thing here is a constraint language for RDF, shapes, so this is from the data shapes working group. Then you have just standards for formats for machine readable data like RDF and variations thereof to model now in RDF 1.1 also quads, various serialization formats for it. Then you have the ontology languages or knowledge representation languages, RDF, schema, OWL, and of course also SCOS. You have these metadata standards, which are more recent, like PROF, and also so to describe the provenance of data, but also to describe data sets like DCAT, so these are actually vocabularies. They could also be seen as vocabularies here, but I just put here additional vocabularies on the side, like the organization ontology, the time ontology. So the W3C actually, for a long time, did not want to standardize vocabularies, but just the languages to describe vocabularies. And at some point, they moved away from this. So they also put a recommendation rubber stamp on certain ontologies. Not many, but a few. Yeah? There are also this data cube vocabulary. Again, it's a question whether you call this a vocabulary or something actually to describe multi-dimensional data. I didn't know where to put it, so we put it in an extra box. So this is to describe mainly statistical data. Then we had some things which are maybe already forgotten, like Gridle. Does anybody remember that? Anybody knows what Gridle is? You see, this was also done in semantic web. It was actually a language to basically link from web documents to how to translate these web HTML documents into RDF. Yeah? So it was basically putting some standard of how to put links into an HTML page to link to an XSLT script to, it was a strange standard. Anyway, so that was more from the earlier days. Sparkle update might be more familiar, I hope, as having been the chair of the Sparkle working group, query languages, and so on. So this is more or less what we can offer as standards. And then there are many more if you take on top of that W3C member submissions. So there was quite some activity in the early 2000s, 2003, 4, 5, on standards for describing web services and semantic web services. So for using RDF and the extensions thereof to describe web services. And then there is things like for rule languages, there was also quite a lot of input what a rule language for the semantic web looks like. That then was merged into this RIF standard, which I also don't know whether anybody of you knows. Who knows RIF? Short show of hands. Yeah, so not surprising, it also was not really taken up a lot in industry. So, and many people don't even know that there is a standardized rule language in the W3C. Anyway, so this is what we have. We can map that to the, so is there a standard for any of these boxes? What do we see? We see some uncovered spots. So for instance, we see here, well, for computational linguistics and NLP, there is not much. For streaming, there is not much. For machine learning, there is not much. For security and privacy, there is not much yet. Huh? So at least in the standards labeled as semantic web standards. There were other standards for policy languages, for instance, or standards proposals in this security and privacy area. But let's have a look what's happening next, or what's currently happening. So the W3C is a bit moving out of putting a standards rubber stamp to all these semantic web activities. But there is still a lot of semantic web related research going on in the so-called community groups, so which are also under the governance of the W3C. There is, for instance, a community group which does something like ontology lexica. So this is some ontology to describe lexica, which could be useful for NLP. So this is driven by some of the core linguistics and semantics guys in our community. I think the chairs are Paul Buitelar and Philip Cimiano of this activity, who you might know, so they're well known for anybody who does linguistics and semantics. Then there is the RDF stream processing working group, who try to basically describe a model of how to express streaming data as RDF and how to query that. Then there is also a community group. Then there is a group there was an ODRL community group. Interestingly, this actually has moved into a real working group. So there is now a working group called the Permissions and Obligations Expressions Working Group in W3C, which is set up to standardize a vocabulary to describe policies and licenses. Yeah? So it was just, they changed the name a bit to have this digital rights out, because digital rights management has sometimes some negative connotations, whereas actually this is much more general. It's to formally describe permissions and obligations, essentially. Good, so then the last area for machine learning, I don't know of any standard which describes machine learning, but what actually could be standardized for machine learning, just thinking out loud, what I would think could be interesting would be a language for having some metadata to describe models, to describe learned models. For instance, regression models, decision trees and so on, and to interchange that with data which you have generated with these models. So this is, I think, something which would be useful to exchange research results or results which you have gained by applying machine learning algorithms to some data, to understand how this data was generated. But this is not existing, it was just something where I think that would be useful. Yeah? And anyway, W3C community groups offer a forum for doing these things. It's a relatively lightweight process to establish such a working group. Good, so this is what we have. And now let's go back to the users. What do the users actually want? So we have conducted 60 interviews, so I mean not 60 interviews, but we have collected 60 user stories from these interviews. And I picking here on 4 of these, which are like, we have kind of had, you saw we had people from HR, for instance, who were more talking about business horizontals, like HR, for instance, human resources management. Our business process people who talk about like product logistics and supply chain management, which are vertical, so which are horizontal business domains. So they are important for any business in a way. Yeah. Then on the other hand, there is what we would typically consider as an application domain, as a business domain, the verticals, like particular sectors, like media and publishing would be one of those, and healthcare and pharma. So I picked those for a reason, because the media, publishing, and healthcare and pharma were, in our opinion, the best fitting ones to these technologies which we think that the community can offer. So if you look at the horizontals, you find not so much of a match of these technologies, at least from what we had for the interviews, because the overall story was more or less, so I would be able to, I would like to be able to exchange information and coordinate production and logistics with suppliers and customers. More or less, they are stuck still with data integration problems, and don't necessarily, all of those people, at least we spoke with, maybe it's just we were speaking to conservative industries, but they were not so much thinking ahead. So maybe then some were mentioned, so that I can improve efficiency. So what you could do, we kind of, to improve efficiency and effectiveness. So that's why these text boxes here are not ticked like recommendation and machine learning, because that was not so much in the focus of these people. So the shades of purple should more or less indicate how important that was, or at least of how important we considered based on the interviews on a very rough raster matrix, so how these technologies would be important. So data integration, data management foremost, and then also the quality of this data. Security and privacy, of course, because, so also for HR, security and privacy, because this deals with sensitive company data, and that is data you don't want to, so you need methods for guaranteeing that it's secure and private. That mostly the difference here is that for HR, they were not so, obviously not so much interested in streaming data. So they were not wanting to hire somebody in real time, if you want. But then there is more on computational linguistics, because they think they can analyze like CVs and so on. So that was more or less a component which was interesting to people from HR, because to find out expertise also from textual data. Good, so we had some coverage here, but not all of the boxes were ticked. So for the actually application domains, this looked much better. We had a really good coverage for these two, for media and publishing. Yeah, so the bottom line, this is just one as example, is I would like to display personalized content as precise as possible, so that my readers stay as long as possible on my website. So they want recommendations, they want text and NLP obviously, and so on. They look, for instance, for images that are relevant for, and so on. So there's all kinds of methods that are important from the semantic web tool stack or technology stack. It's not a stack, but from these boxes which are relevant to media and publishing. Healthcare and pharma, interesting, was really the ones who were most convinced that they can do something with these technologies and most interested in these technologies, who would like to integrate disparate systems, healthcare records that are actually hard to integrate. They have lots of data, they have huge amounts of data, they have data where they have mismatches, that they have inconsistencies in their data which they have to resolve, and so on. So this seems to be a use case which in the interview there was in generally a very positive attitude towards the technologies that semantic web can offer. Good, so the bottom line is more or less that these verticals were more interesting for us. So according to our interviews, these two were the best fitting ones we can offer technologies with. Now, what can we actually offer? Okay, so what can we offer as a community? Because I told you already, these standards alone, if I just look at the semantic web standards, then I probably don't have a really complete picture. Good, so if you look at this box, I said to you already in the beginning, I guess this is more or less, if you ask somebody what technologies can computer science nowadays offer, you probably get the same, right? So it's not really good to have this. So in a way, it's like, and this is also a danger often in papers when you see that, or in conferences that you see, I did semantic web for, you name it, for whatever you want. So, or link data for XYZ. Where the foremost question should always be, what is the unique selling point for using linked data or semantic web in this area? So this is a bit too broad maybe. So what is it actually that our community does? Do we really do everything, or do we do certain things better or worse? So what we tried, at least, and this is kind of still ongoing but not finished, was also to analyze a bit in an introspective view what we can offer as what is our unique selling point as a community. And we can do this by analyzing our research. How can we do that? We can either just look at seminal papers. So these are 3 kind of recommended readings. The first one probably everybody knows. It's this Scientific American article from 2001, where I think semantic web was branded as an idea by Tim Berners-Lee and others. The second one, so this is nice because it's more or less fits nicely with the timeline. One more article appeared in Scientific American about the semantic web. It was called the Semantic Web in Action, which was kind of taking a snapshot at that point where we are with semantic web technologies by Lee Feigenbaum, Ivan Herman, and others. So it was people from the W3C involved there, and they were taking a more practical approach to analyzing what semantic web is. And then the last article recently appeared, and I would recommend this as a reading quite a lot. It's called A New Look at the Semantic Web, and it offers basically a perspective from the view of now. So if you want, you could call it, does anybody know that figure? That's the wise old elf. So anybody who has kids might know this. That's from Ben and Holly's Little Kingdom. So these are the, this is more or less asking the wise old elves. Yeah? So that's what we could do. The other way we could do that would be monitoring the semantic web community's major venues and look at what are the trends in these major venues. So for instance, the ISWC and ESWC conference, we also had data from the semantics conference because of our partners we had, and the major journals, Journal of Web Semantics, Semantic Web Journal. We didn't get all the data of all these venues for back to 2001, but from 2006 onwards we had a quite complete picture. So the Semantic Web Journal just exists only since 2010. That's why it's only since 2010. Good. So I admit this is so what I present to you now is a not yet very scientific approach, but it's more or less an idea of what we could do to introspectively look at our community. Yeah? And maybe it's also interesting or controversial to oppose some of the statements made in these papers with some numbers. Yeah? So let's see what we can do. Here we have this article about the semantic web from 2001, which essentially defined an ontology of semantic web topics. So it started with these high-level topics, expressing meaning, which was about annotation languages essentially, knowledge representation, which also talked about inference and logics, ontologies as common formal knowledge bases, agents technologies, and evolution of knowledge. So let's see what are some quotes from this article. Basically, yeah, we want to be able to express data and rules for reasoning and logic. So there was lots about knowledge representation in this article. And then we could ask ourselves, how has knowledge representation-based research evolved over time in our community? So the good or bad, whatever you want to call it, thing is that, I mean, so it's it's a topic. Knowledge representation, reasoning, inference is something which is still very strong in our community. So that these graphs which I produce are now have been produced completely naively. I just picked the right keywords, maybe, I don't know, yeah, to support my claims. But basically, we are still doing a lot of research on knowledge representation topics and focus a lot on reasoning, inference, languages, etc. So basically it's word counts from the full texts over certain keywords. So I used here knowledge representation, reasoning logics, description logics, and inference and the likes, and just summed up the counts to get to some graphs. With the help of Sabrina and Javi, who were in the first slide, who did that collection. Good. So if we want to maybe get some more insight of that, because that doesn't tell us much, what at least we could see is that it seems that over the years these events might have diversified a bit. Yeah? So we see that knowledge representation and reasoning, I don't know why there is this one peak here, but it looks like semantics is a bit more practical and ISWC is very theoretical, and for other conferences, so here for the journals, they are maybe on par. I mean, there are always these ups and downs, which I admittedly can't really explain yet. But this reflects a bit what my suspicion was. So that reasoning and formal theoretical parts are more covered or still in the focus of ISWC, and other conferences like semantics try to go more in a practical direction, which is also how these conferences maybe understand themselves to some extent. Okay, so agents technology is an interesting point that was stressed a lot in these beginning years. Agents, services, automatic services, where they say software agents will increase exponentially. Well, in reality, this might be true, right? So if you have things like Siri or whatever, which you carry around in your mobile, could be seen as a software agent. Is this also what we do in our research? So is agents a hot topic? Again, naive approach, counting agents, web services, software agents, agent-based, and these keywords. I see that this has not been so popular, it seems, right? So for instance, if you look at it compared to ontologies, ontologies seem to have been picked up much more with the research community. So much more people in our core community at least work on ontologies than have worked on agents. Okay, so evolution of knowledge is mentioned as a fourth topic. Again, so tendentially it's going up. No statistic significance or anything implied. Yeah? But still, we see what is interesting is that this is relatively low in comparison to other terms. So what I did here was like temporal reasoning, temporal semantics, evolution, knowledge evolution, etc. So anyway, if I counted all terms I could think of which have to do with evolving knowledge, it was still much lower. This is going up to the 1,000 mentions per year, maybe, in all this paper corpus, which is much lower than this, even the agent, or not. Agent is going lower now, but it's not. So it's not so much on focus, or hasn't been so much on focus. So maybe a niche which is interesting to work on still. Okay, so then, sorry for that, so that was, okay, so wrong overlay, but this is the second article I want to look at. So we are now in 2009, what happened in between, yeah? So this is kind of, some people have called this the year of linked data, so because this was more or less when linked data was becoming really popular and picking up with these first iterations of the linked data cloud from being 2008, 2009, I think. DBpedia was relatively new, and really hot then. And then basically, so what this article did was, interestingly, they focused a lot on use case domains. They focused a lot on companies. They mentioned a lot of companies which have applied semantic web technologies, kind of like our showcase companies. You have here things like Maitre, that's defense, I think, Chevron, British Telecom, Boeing, Ordnance Surveys, mapping institution in the UK, Eli Lilly, Pfizer, healthcare, Agfa, and then health the National Institutes of Health, etc. So, and then you had also companies mentioned who were like early adopters. So industry vendors who implement and take up semantic web technologies. Oracle, for instance, started to incorporate semantic web technologies in their tools, which they still do. Then it's also Adobe, Altova, OpenLink. So Altova is a smaller company. OpenLink is also a smaller company, but guess well known in our area for their triple stores, top quadrant as well. Software AG is a big German software vendor. And all these were mentioned to implement and actually use semantic web technologies and standards. So if I try to, so how can we see something in the data of the companies? We could have a look. So I tried to answer this question: did companies sustainably adopt semantic web technologies? But this is honestly not really. I can't really answer that from the papers. Yeah? What we then rather try to do is was to answer which verticals and domains companies work in, who sponsors these events, not only who is mentioned in the papers, but which companies are mentioned in the papers, but also who sponsors the event. So we also gathered the data of who was sponsoring these semantic web events, and then see more or less how this developed. So I said already that this was completely non-conclusive. So when I looked for these companies mentioned in this article, they were mentioned 2 or 3 times, so forget about that. So even if I put in OpenLink, so not the use case companies, but the technology vendors, then I would get, just by counting the words, much higher. So this would kind of disappear. This is just adding to the previous start, where there were the companies who had use cases, adding some more companies. So that's not really getting us anywhere. I see I have to maybe speed up a bit. So let me explain you this. So basically this was looking at who was sponsoring the semantic web companies and how often these sponsors were mentioned as doing something with semantic web or whatever in papers. Then you see basically, so we just picked the sponsors because we didn't know which other companies to start with. Only extracting terms was a bit difficult. So then we see Google, Oracle, Yahoo are the most mentioned ones, not so surprising. Maybe it's more interesting to look at the business domains. So something mentioned in this paper was focusing a lot on healthcare and life sciences as use cases. So this is also interesting. So the most use cases mentioned in this seminal paper were about healthcare and life sciences, which was great because this was also one of the use case areas that we identified when talking to people as one of the most promising. So if I look at, is this mentioned in the papers, then I also get to something interesting, maybe not conclusive, but interesting, that for instance, media was, according to our rough classification of domains of this paper, use cases, the most prominent one, which is good, because it also confirms what we had, but healthcare was way down. Yeah? So healthcare use cases were not mentioned so often in our papers, in our core conferences. But there is probably a good explanation for that, which is that actually linked data and semantic web are really established technologies in this domain. So they don't publish in our core conferences. And I was looking at one colleague, Michel Dumontier's, basically publications. He works in biosemantics, so he's one of the leading guys in that area. And he publishes in other venues. So I found, for instance, this journal, which is an journal on biomedical semantics. So they have own journals on semantics, which are very important. And if you want to look on applications in healthcare, for instance, on semantic web, you probably don't look in our conferences, you rather check these special journals. Okay, applications, just quickly. So they were saying, and now the time starts where we have many end-user applications. So maybe we can see whether there is evidence for this in our corpus. Okay, so this is basically going up a bit. But anyway, you could also, that doesn't show too much, so there is much more mentioned about systems, tools, and toolkits. We also have in-use tracks, and maybe we don't, so many of these conferences don't really have papers for the in-use and application and the industry uptake papers, so maybe we just don't find it in the papers. Okay, but I think this is a true statement, that there is more applications, which is good. So the last paper is this last one, which I recommend you to read. So just quickly what this says is that we are basically leading to larger, more applied systems, less formal systems. For instance, a term in the context coined by IBM, I guess, is called cognitive computing, which is basically which actually brings together again symbolic and sub-symbolic approaches. So you can't deal just with symbolic reasoning and ontologies, but you also need statistical methods and non-crisp methods of reasoning, which is a kind of a no-brainer, and many people say this in tears, but they have given it a name, and this is gaining much more popularity. Also, for instance, Watson, as I mentioned, IBM, was using semantic web technologies, so they used DBpedia knowledge inside, but they combined it in a weighted approach with other knowledge bases or with different methods to kind of assess the probability of an answer to be correct. So there is less formal and less precise methods being used, more shallow semantics, and that makes it wider applicable. That's what the paper says. So I tried to basically find that kind of a proof. It's not really a proof, so this was just trying to find whether it's really more applied. But you see, I mean, precise is not mentioned so often. Lightweight is not mentioned really often, so you can't really say something about that. Big data is, of course, on the rise in our papers as well, and so on. So anyway, they also give an outlook in this paper. What could be next? So they say that logic-based methods will be combined with evidence-based. So this is basically the Watson story. There is more intelligent applications by this and so on. Okay, so what did I want to do here? I wanted to basically more evidence-based. Okay, this was not really clear. Then more things about diverse representations of data, lightweight, needs-based, pay-as-you-go is mentioned, mobile applications, and so on. Again, when I typed in these words, I didn't get anything conclusive. What was maybe interesting there, and that's what I think is an important point, is that we have to deal with, we need tools that assess the quality of data and provenance in the realm of this being more evidence-based and so on. And actually, this is interesting because this is something which is trending or going up. I don't know, again, why it's going down here. I have to look into that again. But provenance is shooting up, and data quality is also going up considerably. Not surprising because this prof standard, I think the work was started around this time, 2010, 2011. It was standardized then, or at least there is one document. The latest recommendation is 2013, I think. Good. So data quality is also going up. What else is interesting? That was puzzling me a bit because along with these topics, trust was going down. So maybe people were not talking about trust anymore, but only about provenance. I don't know. But still, it's a bit surprising that trust is mentioned less, while provenance and data quality are going up in mentions. So you see also maybe it was a naive approach, but I'm trying to make my point that these topics like data quality and provenance are gaining more importance. Okay, then there is some things about latent semantics. Crowdsourcing, I want to point out, was mentioned in this article. So these are the questions from this article, which more or less, you can read the article, it's all in there. So that's more or less some questions to the community, which the authors, the wise old elves, consider as the most important research questions. Good, so then what you really see is crowdsourcing shooting up there. Okay, I guess I have to come to an end at some point. So stream data is something going up, dynamic data, yes, that's true. So let's see what can we come up with this analysis. Yeah? As I said to you already, this was quite naive, and we tried to do a roadmap from it. It would be actually dishonest to claim that we have really managed to prove any results with this analysis I've done so far. So I told you it was simple keyword count in words. But that also gives me the opportunity to also take the role of a maybe not wise old, but of an elf in telling you some things. So, and that's kind of what I believe, which are the interesting and hot topics in semantic web. So first of all, I think combining open and closed data, which needs privacy research, which needs security, which is quite under-researched of how to do this, and have formalisms for that in our communities. There are workshops for that coming up, like Prevon and so on, but it's not something which is present a lot in the conferences. Archiving and storage of temporal data, so there is lots about like web data archiving, but not so much about archiving and querying archives of structured data. So when linked data is presented to you, usually just have linked data which is about a snapshot in time, not so much about how to store and query really the evolving linked data. And then there is lots of not so structured data, right? So we need to forget a bit about to always think about all data needs to be in RDF, and we need to convert all the data in RDF. That's boring. There is other data which is in CSV, in JSON, which are also structured formats. And we don't need to convert that to RDF to make sense of it. Yeah? Semantics and semantic technologies can also deal and should also deal with those data. Syntax doesn't matter. Huh? Then cognitive computing, I mentioned already that I think this is something which is really interesting to look into. And analyzing our own research and its impact properly, because I didn't do it properly. Yeah? So giving back to the community, what we will do with this data which we produced in that project is we want to play it back. So we collected the data from different sources. Scholarly data was the former data semanticweb.org, which has some of the conference data, but not all. Then the colleagues from Rexplore, which is also a project doing research data analysis, gave us some data, and also from the Semantic Web Journal, who also have an endpoint. So we tried to put this data together, and we want to play this back into scholarly data, which is mainly key phrase extraction data, which we added. From the full text, we have to look now whether we are allowed to actually publish this, because we might run into license issues. I'm not sure yet. And we complete the missing data there, because we added more conferences. So they were happy and will collaborate to get that data on board. Also, this company and sponsorship data we want to publish. There is, so still a lot of to-dos in this research. So we have lots of skews in the data which we did not bother to remove so far. But maybe until the project we can improve a bit on that. So I just mentioned some things there. We don't have proper stemming there. I did a lot with just combining the different stemming versions of the keywords and so on. So we used this pool party tool. I have to mention our partners because that's what we use to do this analysis. It does some stemming, of course, and that's what we used for this basic analysis. And that brings me quite in time to the end of the talk. Which is the key take-home messages. So we will publish the results on this webpage, linkedata.at, which is this Propel project webpage. So don't think that our standards are known by industry, although it's standards supported by industry, which are all the standards at W3C. Unfortunately, they're not as widely known as we might think as academics. Although standardization was, of course, a really good vehicle to push semantic web. And it's useful. And I think we could still need some more research to understand what we actually do and sell our successes. So we should listen to the wise old elves. But so we could also do a more data-driven analytics of the successes of our communities. And of course, it was much too focused to just look at our venues, but we could see other data on the web or elsewhere to find out what impact semantic web research actually had. And the last thing is we shouldn't try to build this egg. Well, what in German it's called eierlegende Wollmilchsau, the egg-laying wool pig. So the monster which does everything. This is not our focus as a community, I think. Okay, so thanks for listening, and I'm glad for any feedback.
Thank you very much. Okay, thanks. So any questions? Yeah, okay.
I come from industry and been using Marina as a source for a while. But a big gap I see is what I want to be able to do with my triple store is run algorithmic graph.
Yeah.
Take
Yeah.
shortest path.
Yeah. So that's a good point. That's what we just discussed in the break before. So the question was on certain graph, basically the basic things you want to do with the graph database, and with the graph query language you can't do them with Sparkle. So that's more or less rooted also by the evolution of Sparkle, which was RDF query language, but basically in the working group there were many people coming from the relational database side, if you want, and we're thinking of implementing Sparkling as a relational database on top of a relational database. And then Sparkle 1.1, which added some graph features like path queries, was just a minor step on top, yeah? But not everything. Still, it's the only, as far as I know, standardized query language for graph databases. So definitely I agree completely that there is a need for standardization for graph databases, because there are exactly these queries and things you want to solve for a graph database. What you said, like, I mean, shortest path, you actually get back that there is a path, that's what you can do in Sparkle, but, so regular path expressions, but you can't get back the paths, things like that. So, and that is not solved. Yeah? That is something where more standardization would be needed, or you just say, I use Giraffe or whatever, Kremlin, one of these other graph query languages, which are proprietary. Yeah.
So the W3C is not looking to extend Sparkle 1.1 into Sparkle 2.0 to include these?
The question is, so these graph database vendors are not necessarily semantic web vendors. Huh? So they maybe say, okay, an RDF we can do as well, but I don't know whether they are actually W3C members or engage there. So some of them are, but not all, and maybe they are fine with this. So there's a big market for them, so maybe they don't feel the need yet to join forces or to standardize something.
I know some of the triple store vendors have proprietary extensions to Spark, like Virtuoso in France.
Yes. So, I mean, as far as I know, at the moment, there is nothing ongoing to extend the standard further, not within W3C, which is also, so it does not seem to be a priority. I don't know, I'm not at the technical plenary meeting, which is taking place this week in Lisbon, so maybe I ask my colleague going there whether there's anything new, but not that I know of at the moment.
Perfect. Last more question.
Just to ask you something about Sparkle 1.1.
Yeah.
It supports updates, operations.
Yeah.
Is it because you?
Yes, there is a specification called Sparkle Update, which supports template-based updates based on Sparkle.
It's part of Sparkle 1.1.
Yes, but most triple stores support that, so that's. Yes, as far as I know. Yeah.
And some different comment. Many linked data and big data are not linked together in terms of data federation. I mean, if you have some Sparkle endpoints like Uniprot, which stores, you can use such kind of statements like service statement for your Sparkle queries. You don't need to store the data in your.
Yeah, so federated, so that's, I mean, that's not service in the sense of service and agents, but in the sense of federated query processing. So federated query processing has its own problems because you have to deal with downtimes of servers, etc. You have to deal with the transfer over the wire of the data. So that what is in the Sparkle standard for federated query processing is something usable and it works. But if you want to perform queries, for instance, where you put, let's say, the DBpedia endpoint in the service thing, you will not have a lot of fun. So the problem is also that there is no standardization about how to advertise restrictions of the triple stores who have a public endpoint. Most endpoints do that, right? So they basically say you can only do X queries per hour, you can only do X queries per minute, you only get back 1,000 results per query, and then we just cut off and stuff like that. And these are mostly not advertised, but you just find them out by pinging the server. Right?
The backward chain reasoning is also the price you pay.
Well, backward chaining reasoning could be done by rewriting it to path expressions. It can. We have a paper about this. So you can do it with a native triple store, but it looks ugly.
Okay, thank you very much. I would leave the rest of the discussion to the coffee breaks and stuff like that because we are already 10 minutes behind the schedule. Axel, I would kindly ask you to chair the next session. which is the last session on ontologies.
Okay, so who's the first one? I need the book.
Yes.
Oh yeah. Okay, good. So I can continue.
Yes.
So should I? This one I give to the speaker. Yeah?
Let's do it this way. Good. Oops. So I swap roles from podium to chair. And we start the next session. So the first talk of the regular talk of the session is about user-driven ontology population from linked data sources, and it's presented by Panagiotis. Yeah, Panagiotis. Mitzias, sorry. Yeah, I hope it was correct enough. Okay. So now that we are late in time, is it also my duty to catch up on time? I hope not. Sorry.
So use. Yeah, you can use this one or. Okay. Thanks. Hello everyone, my name is Panagiotis again. I have come from Greece here to present you our work on ontology population and show you a tool that we have created. I work for a research institute in Greece called ITI, and we participate in a research project funded by the European Union called Pericles. So what led us to work on ontology population was the increasing interest in building ontologies and the fact that populating them manually is quite painful. Also the fact that there are multiple sources of living data. What we intended to do was to facilitate the population process by automating it and by supporting input of knowledge from many sources. So this is the outline of my presentation. First I'm going to give you a few details about Pericles, and then I will show you our tool, which is named Prophet. This is what Pericles stands for. It mainly deals with digital preservation of digital content. As I said, it's funded by the European Union, and it ends at this January. What ITI does within Pericles is to design and implement certain domain ontologies and then populate them. Pericles' main aim is to ensure that digital content remains accessible in a continuously changing environment. These changes might be technological development, change in terminology, semantic drift, change in processes, or perhaps in the involved communities. So this is our logo, Prophet, which stands for Pericles Ontology Population Tool. What Prophet offers is 3 modes of instance population: class-based, instance-based, and instance enrichment. It requires certain mappings between classes and data properties to be done by the user. And then the user can export the populated ontology in any of the popular formats you can see. Prophet intends to work with any old ontology on the user side and any Sparkle served endpoint on the external side. So this is the main architecture of Prophet. On the left you can see the front end, which is the user interface developed in Python. In the middle you can see the back end, which is also written in Python, and we used some very popular libraries such as RDFlib. And on the right you can see the external resources that are used. It's the user's ontology, the local model, the external model, which is the linked open data source, and the database that we use for persistent storage. So these are the core components of the software. Firstly, my model is the ontology that I want to populate, and I have to load it into Prophet. The external model that can be, for example, DBpedia. The extraction module includes the search mechanisms that are offered, so you can search for instances to populate your ontology. There is the mapping module where you need to perform mappings, and the storage module is the database. Finally, the export module is to export the populated ontology. So for searching, there are currently 4 modes. You can search by class. For example, if I have a domain ontology that I want to populate with instances of artists, I can directly search for instances in the class of DBpedia DBO artist. Secondly is search by instance label. For example, if I am looking for an instance of painter Picasso, I can type Picasso and find instances with this label. Search by existing instance is when I want to find some instances similar to the ones I have already in my ontology. Again, for example, if I have an instance of Picasso and I want to find instances of other Spanish painters, I can use this function. And finally, enrich existing instances by locating desired data properties and their values and importing them in my ontology. The mapping module firstly requires from the user to define a specific class under which the new instances will be imported. And then the user has to map the external model's data properties to their local ontology data properties, so we can transfer the values. And those mappings performed by the user are stored in the ontology, so for future use, the software comes up with suggestions of mappings. Here you can see the main user interface of Prophet. On the left you can see that I have loaded a very simple ontology with 2 classes, my ontology artist and my ontology artwork, with a couple of instances for each one. And on the right you can see the 4 search mechanisms and the button to export the populated ontology. So let's take the example that I want to find an instance of the artist Vincent van Gogh. I would search by instance label, the first option on the top right. So this menu would pop up. I would write the label that I want to search for, and the tree presents the instances that were found in DBpedia. I can select 1 or more instances here and press next. Here is where I have to define that the new instance that will be imported in my ontology will go under class my ontology artist. And this is where I have to perform the mapping between properties. On the left side, you can see all the data properties that the instance of Vincent van Gogh has in DBpedia. And on the right, there are drop-down menus where my ontology's properties are showing up. So, for instance, if I want my instance of Van Gogh to be connected with a data property of birth year, I need to perform the mapping of DBO birth year to my ontology year of birth. For those that I leave empty, no values will be passed to my ontology. So this is a summary of the instantiation that I have done. You can see that the new instance was created and all the data properties that were passed. And finally, this is the initial window where you can see again my whole ontology, which now contains Vincent van Gogh. When the first version of the software was published, we asked from 15 people to perform an evaluation, to try the software and give us some feedback. Most of them were familiar with ontologies, and they gave us quite a good feedback. As you can see, we intend to do a greater scale of evaluation. To summarize, we tried to make a software that is user-friendly, that makes ontology population simple. The user does not see any Sparkle queries, so they don't need any experience on this. We provide 3 basic modes of population, and the user is required to perform the manual mapping that I showed you before. As a future work, we intend to handle also object properties and not only data properties. We are trying to make it a plugin for Protege, and we will also add some search options that we have thought. Okay. I think it was soon enough. Thank you very much.
Questions?
Why didn't you just start as a Protege plugin?
That's a very good question. We wanted something independent for the project, for Pericles, as a standalone tool. And we had in mind from the beginning that the next step is to make it a Protege plugin. Yes, please.
Is these slides available online somewhere?
Not yet, but I could send them to you if you want.
Exchange.
Yeah.
Some more questions? So I have one. What I was interested in was basically the tool you presented. It's basically used to populate one ontology with instances from another, right?
Yeah.
So what is the driving use case from this project? Because usually FP7 EU projects, they need some use case to make progress. So where would you, I would just be interested of the context in the project of this.
Yeah, we cooperate with Tate Galleries from London. They have artworks.
Okay.
And some use case scenarios are about digital artworks. And how they should be preserved.
Okay.
For future
so
use.
There you're trying to find whether, for instance, some artwork is already available in like DBP or something, or not?
No, actually, we are building the domain ontologies about those types of digital artworks, and we will populate them with Tate's artworks, and we want to be able to populate with data properties from DBpedia also and other sources.
Okay.
and
So
not
that's
do
why
it manually.
I was asking. So to me, this sounds like at the core of the problem, like instance matching, which is a much researched field in ontology matching, right? So there seems to be maybe a lot of related works in this area.
There is a lot of work. We wanted to make it as more independent as possible. So we tried to make it work for all ontologies of the user side and all Sparkle served endpoints. So we thought it's better for user-driven mapping and not use other technologies that already exist.
Ah, okay,
Sure.
so you support like an intuitive way to define the mappings. That's what you're saying. Huh? Okay. Something. Okay.
I think I got what you're asking me. Sorry.
Okay. But we can discuss it further offline. So thanks again. And the next speaker is Christian Wojciewicz, who is preparing and will tell us. Oh, sorry, the next speaker is not Christian. It's who is the next? Jana. Okay. So Jana, Ahmad will present us a paper on ontology anti-patterns in aviation safety event models.
Martin? Yes, sir. Where is it? Okay. Good afternoon. My name is Jana Ahmad, Department of Cybernetics, Faculty of Electrical Engineering, Czech Technical University in Prague. In my presentation, I would like to discuss some type of conceptual modeling anti-patterns that lead to error-bound modeling decisions that we observed during our work in design and model ontologies in the domain of aviation safety. Our approach is based on models designed by OntoUML. That's why, first of all, I would like to explain main concepts in OntoUML. OntoUML depends on UFO, which is Unified Foundational Ontology, which is top-level ontology that designed by Khegai in 2000. What is the goal of UFO? I would say that what is real is what one must make reference to, giving a description of reality. That's why UFO had to provide ontological foundations for conceptual modeling most basic constructs. UFO is divided to 5 layers. UFO, the first layer, is designed to model endurance, I mean objects and aspects. UFO-B is designed to model endurance or event. UFO-C to model social reality, which is extended now to UFO-L, legal relations. And UFO-S is designed to model services, I mean to model commitments and claims in services or agents. This picture shows the relation between This picture shows the relation between concepts of domain ontologies and concept of the foundational ontologies and OntoUML, which is used to compose conceptual models. OntoUML uses ontological distinctions between or amongst categories of objects between objects, subkinds, roles, and between two relators and relations, like formal relation and material relation, and between events. We are interested in model ontologies in aviation safety domain, especially aviation safety events. That's why we are interested in UFO-B layers. This picture explains the main concept in UFO-B. Every event has either complex event or atomic event. That depends on how many parts that event consists of. And every event has object as participants. That's where OntoUML editors doesn't support UFOB concept. That's why we found out that there is a need to extend OntoUML meta model to use verdurant and individuals in universal event type. And we could add event stereotype and participant relation that connect events to their participant. We could add them to OntoUML editor called Polleres. And this model I did by OntoUML editor by using our event stereotype and the relation participant of relations that connect this event with its participant. Anti-patterns model. The objective from all that I said before is to model correct models and indented patterns. But still we have anti-patterns model. What is anti-patterns model? Anti-patterns model is modeling pattern that, despite reducing syntactically valid conceptual modeling, is prone to the B source of domain-related ontological misrepresentation. Why? This is because the admissibility of domain-specific state of affairs depends on domain-specific rule, not on the ontological one. Ontological anti-patterns in U4R. Now I will mention some types of anti-patterns that exist. Relation between overlapping subtypes, anti-patterns. This type of anti-patterns happens when we have supertype with two subtypes and there is a relation between those subtypes. For example, here we have person-like kind and student and instructor. In the instance level, maybe we have the same person, a student and instructor in the same time, and it's anti-pattern. Ontological anti-patterns in U4B, which is basically our work. And besides abstraction anti-patterns, this type of anti-pattern happen when we have two events, and one of those events has at least one subtypes, and there is a relation between those events. This picture is taken from the Riga ontology that designed to model RAM system event. Here we have contributing factor event which cause airdrome operation, some of airdrome operation in the domain of aviation safety. And this event has those sub-events. This pattern has anti-pattern because in the instance level, maybe the airdrome operation is necessary to happen the existence of supervision or individual factors. And this pattern doesn't guarantee this situation, and that leads to undesired result. Ontological anti-patterns in U4B. No, I said. During our work in modeling hazard event in aviation safety domain, we faced some of anti-patterns or undesired results or consequences. That lead us to define a new type of anti-pattern. This type of anti-patterns happen when we have two events with a joint sub-event, and this sub-event causes another two events. For example, this picture is taken from hazard taxonomy ontology. We have psychological action procedure violation, which cause runway incursion or pushback that happen in order if this event belongs to human factor or organization factor. The anti-patterns in this model, for example, maybe we have runway incursion that cause from psychological action procedure violation that belongs to organization factor, and it's not correct. It has to belongs to human factor. So the solution of these anti-patterns is to delete these sub-events, the relation between those events, and make this event relate to a general event, and add two relations that connect those events. It's our work. As conclusion, we discussed how ontological anti-pattern cause undesired consequences in ontological conceptual models, especially in aviation safety event models, in order to help designers to produce intended model and increase the accuracy of conceptual models. Also, we try to improve a conceptual model assessment tool based on unified modeling language UML that assumes a well-founded conceptual modeling language named OntoUML. Thanks.
Thank you. Questions? No questions?
Did you try, I mean, did you try, is there any implementation of this? Of those anti-patterns and detection or something like that?
No, there is no implementation of this antibiotics. There is an implementation of event and stereotype and participant of relation.
So these anti-patterns are used for detecting like abnormal behaviors or?
Yes.
Yeah, so I mean, this is an ontological construct, so in these upper ontologies, which is not typically present in like languages like ours, you can't express these kind of things, right?
Yes, it's
So-
right in syntactically way, but it's
Yes.
but
Is there, I
it's
mean,
into
I'm asking because basically some ontology languages are just based on first order logic, and you can, the advantage is if you stick to this, then you can use reasoning tools which you have off the shelf, right? So can you do this with these ontology languages as well, which relates a bit to this question whether there is an implementation?
yes.
And what kind of formalisms would you translate this to?
We need to transfer use logic and some OCL constraint to make this implementation.
Yeah, but is that just all expressible in first order logic or not? Because it looks a bit like non-monotonic constructs to me.
I don't.
Okay. More questions? Then thank you again.
Thank you.
And we come to the last talk. So now I'm at the right one. Maksim, Khegai, will present on an ontology for performance control in service-oriented systems with composition services. Or is this another person presenting at least? Sorry, that was correct.
Just go to
No, it's Maxim.
Hey, good evening, everyone. My name is Maksim, and I'd like to give a brief overview on our work, which is use of ontologies for performance control in service-oriented system. First, I would like to talk about our motivation for this work. Then I'll give you an overview of a typical model of such a system with service-oriented architecture. I will tell you about the ontology approach to services description and tell you a little about the test case that we described in our paper. So, the motivation is next. The service-oriented architecture for servers becomes more and more popular. And services in such servers are distributed and loosely coupled. That helps to solve an issue of providing scalability, since such services are loosely coupled and can be changed or added or even removed without heavily changing the configuration of a server. Now, since they are loosely coupled, they cannot interact with each other without having some information, and that demands of some information storage and the means to store that information, and such means are use of ontologies, and they are actually actively used for computing systems for description of systems infrastructure. And since nowadays service-oriented solutions are placed in cloud infrastructure, that helps with providing the performance we need. So, a system with service-oriented architecture from a software point of view is a set of applications. And those applications form services. Because of that, services can have one or several interaction applications. And since those services may have very different goals, different requirements to environment require services to be deployed on separate servers. For example, if one server needs Linux operating system to function normally, and the other service demands Windows or even Mac OS. Now, as I said, a system has a few servers. Oh no, sorry, I didn't say that before. A system has a few physical servers, and one of them is always the main server that actually has everything that the system needs to function normally. Every physical server has a few virtual machines inside. Those machines have services that process jobs. And a service, as I said before, may include one single application or several interacting applications which process those jobs. And in a lot of situations, when processing leads, in a lot of situations, processing those jobs leads to a competition for resources between services. And now here you can see that in a model we have a jobs queue. Jobs queue holds every job that was received by the system. And as you can see, a job may contain only a single application, or it may be a composite job that it demands processing in different applications in a queue. As you can see, since we have different services that contain different applications, they can contain even similar applications. We have a few ways of executing a composite job. We have the way number 1, and we have way number 2. Basically, all we need to process a job is to pass it to different applications. Now, the performance of the system constantly changes with time, and main factors that influence it are number of simultaneously processed jobs in the system and in a separate application, and the placement of applications in virtual machines, and placement of virtual machines in physical servers as well. So why is that so? Because different virtual machines might have different resources allocated to them. And if we have a lot of work in virtual machines that demand more resources that it was allocated, we actually have a big decrease in performance. Now, solutions exist, and the solution to performance optimization is may be separated in 3 different tasks. The first is monitoring of performance and available resources of each server. The second is quick search of a path for a job to be processed. And the third one is storing knowledge about systems, objects, and efficiency of decisions in path choosing for different jobs type that were actually made before. So we don't actually need to calculate each path every time we need it. And here you can see typical architecture of a server. Now we have the main server. As I said, it contains the knowledge base and the data storage with different applications. And we have 2 computing servers that contain those applications. So the knowledge base is formed by 6 connected concepts. The first is physical server. The second is a virtual machine. They are actually connected together because a virtual machine cannot function normally without physical server for obvious reasons. And the third is a telecommunication node, which describes mainly telecommunication devices such as router, switch, or hub. And in the system that we described, we used a virtual switch. Now the fourth concept is the service. The fifth is application, and the sixth is job. They are interconnected as well, for obvious reasons as well, since the service holds applications and the applications process the jobs. The ontology itself looks like this. You can see concept virtual machine, the concept server, service, job, and application. As you can see, the concept virtual machine and service has performance as its parameter, and this is where we hold the performance that we monitored before and that we use in the future predictions of how performant the system will be. Now the control strategy in the test case that we used can be separated in 3 steps. The first step is queuing. It's the simplest one. We just put the jobs in one single queue and then allocate those jobs to different applications. Now, if we don't have enough resources to process the jobs, we get to the step number 2, and that is virtual machines migration. Which means that we may reallocate virtual machines to different physical server that has free resources. And the third step, which happens if none of previous steps work, we manage applications number in separate services. So the services actually process less jobs, and that increases the performance, but this step is the last resort. This is the workflow of the whole system. You can see that at first we analyze the job, we see which applications it needs to be processed. Then we try to find a virtual machine that can process the job. If that virtual machine is found, we actually get to determine the path or the sequence of applications that will process that job. And if the optimal solution was found, we process the job and give the output to user. If it wasn't found, we redistribute applications, migrate virtual machines, etc. So in conclusion, we demonstrated that approach to information providing for performance control in service-oriented system with composite services exist as we imagine it. Modern cloud computing platforms have tools to provide data exchange between system objects components, and that provides us with means to hold and use the information we store. And the future of this work will be in development of the study. Is in improving decision-making algorithms and improving control strategies. So the system will be even more efficient, or at least we hope so. Thank you for your attention. If you have any questions, I will gladly answer them.
Thank you. Questions?
I have a question, and that's really, so you tried to somehow match this model that you created to existing standards for certain test For example, on the inference level to old S, plain old, or for example, on the conceptual level to UFO S or another top level.
Well, not exactly. We were studying developments that were made by other people, and we actually found out that in general this is how the infrastructure looks. So for future experiments we will use this infrastructure, and if everything goes well, we will publish another paper on that.
Similar question, but just curious, have you heard of Hydra?
No, I don't believe so.
That's a W3C work in progress standard for service description based on RDF as well. It seems closely related, not the same, but
Yeah, well, I guess there are a lot of work like this, and you can't really make something really different, but you can make it stand out by using other methods or making it better.
this is a W3C standard also, but it's in the process of being a standard. We're investigating it.
So maybe worthwhile to discuss after the session and exchange some more thoughts. Maybe one more question. So the use case you presented, which is basically about like dynamic hardware allocation or something like that. I assume that this sounds a bit to me like first thing I would come to would be, okay, that's probably what people who do cloud computing or cloud infrastructures already do. Or historically, this has been investigated maybe in the context of grid computing, or basically just to mention like two other like names for maybe the same thing. Or what do you say? What would be the relation?
Yeah, I do believe we mentioned a few names in our work in the paper, and we actually right now the system with such infrastructure is in prototyping step at our place, and it is web service cloud system. So we plan on testing this concept on that prototype.
Okay, so maybe we can discuss further and close the session. And I thank you again for your talk.
Great.
So thank you. Today we are at the end. Tomorrow we will meet here at 9 at a keynote by Linda Hartmann. So be ready for a long day, because we are ending with social dinner. And after the Stefan Stab, so tomorrow we have two keynotes, one in the morning and the other in the evening. Stefan Stab keynote is in the evening. Afterwards there is a poster session, and right after the poster session we will meet here and go and walk to our place where the dinner will be. So we have just planned with our guide where we shall go, so be ready for a nice walk, 1 hour approximately. Thanks.